Hello, and welcome to my channel, where we explore the wonders of the human body, one gentle discovery at a time. Tonight, we're venturing into a hidden world that exists right inside you, a bustling metropolis of microscopic life that's quietly orchestrating more of your daily experience than you might ever imagine. We're talking about your gut microbiome, an invisible organ that doesn't appear on any anatomy chart, but may be one of the most influential parts of who you are. Before we begin this quiet journey into the microscopic realm within, I'd love to know, where in the world are you listening from tonight? And what time is it in your corner of the universe? Are you settling in for sleep in Stockholm, or perhaps winding down after a long day in Sydney? There's something rather poetic about the fact that no matter where you are, the same invisible community we'll explore tonight is thriving inside you, working tirelessly while you rest. If you find these gentle explorations of science soothing, I'd be ever so grateful if you gave this video a like and perhaps subscribed for more peaceful journeys through the mysteries of life. It helps other curious souls find their way here, and it means I can continue crafting these soft scientific wanderings for you. Now, I do hope this isn't so fascinating that it keeps you awake, though. If it does, at least you'll drift off knowing a bit more about the extraordinary universe that lives within your own body. So settle in, get comfortable, and let's take a slow, thoughtful exploration of your gut microbiome, this invisible organ that's been with you since your very first breath. Picture this. Right now, as you're listening to these words, there's an entire civilization living inside you. Not metaphorically, but literally. Trillions of microscopic beings, bacteria, viruses, fungi, and other microorganisms are going about their daily business in the warm, dark corridors of your digestive system. They're communicating with each other, fighting off invaders, manufacturing chemicals, and influencing everything from your mood to your immune system to your cravings for that late-night snack. This isn't science fiction. This is your gut microbiome, and it's one of the most remarkable discoveries of modern science. For most of human history, we thought of bacteria as the enemy, nasty little germs to be scrubbed away with soap and eliminated with antibiotics. But it turns out we've been living with the most extraordinary roommates all along, and they've been taking care of us in ways we're only just beginning to understand. The word microbiome itself is relatively new, coined only in the early 2000s by a scientist named Joshua Lederberg. It refers to the collective genetic material of all the microorganisms that live in and on our bodies. But when most people talk about the microbiome, they're referring specifically to the gut microbiome, that teeming community of microbes that calls your intestines home. To put the scale of this invisible world into perspective, consider this rather humbling fact. The microbial cells in your body outnumber your human cells by about 10 to 1. In other words, you are more microbe than human, at least numerically speaking. If you could somehow line up all the bacteria in your gut end to end, they would stretch around the Earth's equator. That's about 25,000 miles of microscopic life, quietly coexisting within the 3 or 4 feet of your small and large intestines. But numbers alone don't capture the true wonder of this hidden ecosystem. Your gut microbiome weighs roughly 3 to 5 pounds, about the same as your brain, and it's just as complex and mysterious. Scientists have identified thousands of different species of bacteria alone, each with their own preferences, behaviors, and contributions to your health. Some prefer the acidic environment of your stomach, others thrive in the more neutral territories of your small intestine, and still others have carved out niches in the vast neighborhoods of your colon. Think of your digestive system as a long, winding river ecosystem, with different communities of microorganisms adapted to each stretch of the journey. Near the mouth of the river, your stomach, the environment is harsh and acidic, so only the hardiest species can survive. As the river flows through your small intestine, conditions become more hospitable and different communities flourish. By the time we reach the wide, slow-moving delta of your large intestine, we find the most diverse and densely populated microbial cities on Earth. This microscopic ecosystem didn't just happen by chance. It's the result of millions of years of coevolution between humans and microbes, a partnership so intimate and essential that we literally cannot survive without it. These tiny organisms have been with us since the dawn of our species, shaping not just our digestion but our immune systems, our brains, and even our behavior. The story of how we discovered this hidden world is quite remarkable. For centuries, scientists peering through early microscopes caught glimpses of these tiny creatures in samples of pond water and dental plaque. They knew microorganisms existed, but the technology to study them in detail simply didn't exist. Most bacteria refuse to grow in laboratory conditions, making them nearly impossible to study using traditional methods. It wasn't until the late 20th century, with the development of DNA sequencing technology, that we could finally peek behind the curtain and see what was really going on inside our bodies. Instead of trying to grow these finicky microbes in petri dishes, scientists learned to extract their DNA directly from samples and read their genetic signatures like molecular fingerprints. Suddenly, a hidden universe revealed itself. The first comprehensive map of the human gut microbiome was completed only in 2012 as part of the Human Microbiome Project. In the grand timeline of scientific discovery, this means we've known about the composition of distant galaxies longer than we've understood the microscopic galaxy living in our own intestines. It's rather poetic, isn't it? We looked to the stars before we looked within. What researchers found was astonishing. The gut microbiome is not just a collection of random microbes that happen to take up residence in our intestines. It's a sophisticated, self-organizing ecosystem with its own economy, politics, and social structures. Different species of bacteria trade nutrients back and forth like merchants in a microscopic marketplace. Some act as peacekeepers, maintaining order and preventing harmful species from taking over. Others serve as manufacturers, producing essential vitamins and chemicals that our bodies need but cannot make on their own. Perhaps most remarkably, this microscopic community is in constant communication, not just with each other, but with you. They send chemical signals up to your brain through what scientists now call the gut-brain axis, a two-way highway of information that connects your digestive system to your central nervous system. When you feel butterflies in your stomach before a big presentation, or when you get a gut feeling about something, you're experiencing this ancient communication network in action. The microbes in your gut are literally talking to your brain, influencing your thoughts, emotions, and behaviors in ways that would have seemed like pure fantasy just a few decades ago. They help determine whether you wake up feeling energetic or sluggish, whether you crave a salad or a slice of pizza, whether you feel anxious or calm, whether you fight off that cold that's been going around or succumb to it. This isn't to say that your gut bacteria are controlling your mind. You're still very much in charge of your own decisions, but they are influential advisors, constantly whispering suggestions based on their own needs and the state of their microscopic world. When certain species are thriving, they might encourage you to eat the foods that help them flourish. When the community is out of balance, they might contribute to feelings of fatigue, anxiety, or digestive discomfort. The more scientists study the gut microbiome, the more connections they discover between this invisible organ and virtually every aspect of human health. There's growing evidence that the composition of your gut bacteria influences your risk of obesity, diabetes, heart disease, autoimmune disorders, and even neurodegenerative diseases like Alzheimer's and Parkinson's. Some researchers now refer to the gut as the second brain, not just because of its extensive neural networks, but because of its profound influence on mental health and cognitive function. But here's what makes this story even more fascinating. Your gut microbiome is as unique as your fingerprint. While humans share about 99.9% of their DNA, We share only about 30% of our gut bacterial genes with other people. The specific composition of microbes in your intestines is shaped by countless factors: where you were born, how you entered the world, what you ate as a child, the medications you've taken, the places you've lived, the people you've kissed, even the pets you've owned. This means that the invisible organ we're exploring tonight is not just a generic human feature, it's uniquely yours. The bacterial ecosystem living inside you right now is different from that of every other person on Earth. It's a microscopic fingerprint that tells the story of your life in ways that even you might not fully remember. And unlike your actual fingerprint, your gut microbiome is constantly changing. Every meal you eat, every medication you take, every stressful day you experience subtly alters the composition of this inner ecosystem. In a very real sense, you are continuously sculpting your invisible organ through the choices you make each day. This dynamic nature of the microbiome is both exciting and daunting. It means that you have more control over this aspect of your health than you might realize. But it also means that this invisible organ is vulnerable to disruption in ways that we're only beginning to understand. Modern life, it turns out, can be quite harsh on our microbial companions. The widespread use of antibiotics, while life-saving in many situations, can devastate gut bacterial communities like a forest fire sweeping through an ecosystem. Highly processed foods, chronic stress, lack of sleep, and reduced exposure to diverse environments can all tip the delicate balance of the microbiome toward what scientists call dysbiosis, a state where harmful species outnumber beneficial ones, or where the overall diversity of the community is reduced. The consequences of this microbial disruption are still being studied, but early evidence suggests they may be profound. Some researchers believe that the rise in autoimmune diseases, allergies, obesity, and mental health disorders in developed countries may be partially linked to changes in our gut microbiomes over the past several decades. But there's hope in this story too. Because the gut microbiome is so responsive to environmental changes, it also offers unprecedented opportunities for intervention and healing. Unlike your genes, which are largely fixed, your gut bacteria can be influenced, nurtured, and even partially restored through thoughtful lifestyle choices. This is where the story becomes deeply personal and profoundly empowering. Understanding your gut microbiome isn't just about satisfying scientific curiosity, it's about recognizing that you have a powerful ally in your quest for health and well-being. This invisible organ, this community of trillions of microscopic partners, is working around the clock to support you, protect you, and help you thrive. As we drift deeper into this exploration tonight, we'll discover how this remarkable ecosystem develops from the moment of birth, how it shapes your health throughout your life, and how you can nurture it to support your own well-being. We'll meet some of the key players in this microscopic drama, learn about their different roles and personalities, and explore the fascinating ways they communicate with each other and with you. So as you settle in more comfortably, perhaps feeling that gentle tug of drowsiness, remember that even as your conscious mind begins to rest, your gut microbiome continues its tireless work. Trillions of microscopic guardians are standing watch, processing the remnants of your last meal, manufacturing vitamins for tomorrow's energy, and sending gentle chemical messages to your brain that all is well in their microscopic world. In a universe filled with vast distances and cosmic mysteries, perhaps one of the most extraordinary frontiers lies not in the stars above, but in the invisible world within. Your gut microbiome, your hidden organ, is a reminder that life is far more interconnected, far more collaborative, and far more mysterious than we ever imagined. The journey of your gut microbiome begins long before your first breath, in a story that would make any novelist weep with its perfect timing and profound intimacy. For 9 months, you developed in what scientists call a sterile environment. Your mother's womb was essentially a microbial blank slate, free from the teeming communities that would soon become so central to your existence. You were, for those precious months, a human being without your invisible organ. But the moment you entered the world, everything changed. Your very first breath didn't just fill your lungs with air, it filled your body with life. Thousands of microscopic immigrants rushed to colonize the pristine territories of your digestive system, skin, and airways. If you were born through the birth canal, you received your first microbial dowry from your mother's vaginal and intestinal communities, a carefully curated starter kit of bacteria that had been preparing for this moment. If you arrived via cesarean section, your first colonizers came from your mother's skin, the hospital environment, and the hands that first held you. This initial seeding is so crucial that some hospitals now practice what's called vaginal seeding for C-section babies, gently swabbing newborns with gauze that has been exposed to the mother's vaginal microbiome. It's a small gesture, with potentially enormous implications, a recognition that we've only recently begun to understand the importance of this microscopic inheritance. But your microbial story was just beginning. In those first few days and weeks of life, your gut became a frontier territory, with different bacterial pioneers staking out claims and establishing the first settlements. Some arrived through your mother's breast milk, which turns out to be far from sterile. It's actually teeming with beneficial bacteria and special sugars called oligosaccharides that exist solely to feed your developing microbiome. Formula-fed babies receive a different microbial education, one that's perfectly adequate but distinctly different in its composition and timing. Your early diet played the role of ecosystem architect. Breast milk contains over 200 different oligosaccharides, complex sugars, that your human digestive system cannot break down. They pass through your stomach and small intestine unchanged, arriving in your colon like perfectly wrapped presents for your bacterial tenants. These sugars have no purpose other than to nourish specific beneficial bacteria, particularly bifidobacterium species that help establish a healthy gut environment and support your developing immune system. It's rather remarkable when you think about it. Your mother's body was producing food not for you, but for the bacteria that would help keep you healthy. Evolution had already figured out the importance of nurturing your invisible organ long before we had any scientific understanding of what was happening. As you grew from infant to toddler, your microbiome grew with you. Each new food you encountered, those first spoonfuls of rice cereal, pureed carrots, tiny pieces of soft fruit, introduced new bacterial possibilities. Some microbes specialized in breaking down starches, others preferred proteins or fats. Your gut became increasingly sophisticated, developing neighborhoods of specialists who could handle whatever culinary adventures your curious little hands might discover. The terrible twos weren't just terrible for your parents, they marked a crucial period of microbial maturation. By around age 2 or 3, your gut microbiome had largely stabilized into what scientists call an adult-like configuration. The wild fluctuations and rapid changes of infancy gave way to a more settled community structure that would remain relatively stable throughout your childhood and into adulthood. But stable doesn't mean static. Your gut microbiome continued to evolve throughout your life, shaped by every decision and experience. That family trip to Mexico when you were 12, where you bravely tried street tacos and spent 2 days feeling queasy, may have introduced new bacterial strains that are still with you today. The antibiotics you took for strep throat in high school temporarily decimated your microbial population, creating opportunities for different species to establish themselves during the recovery period. Your first kiss wasn't just a romantic milestone, it was also a microbial exchange program. Studies have shown that intimate partners share similar oral and gut microbiomes, gradually swapping bacterial communities through close contact. In a very literal sense, you become more microbially similar to the people you love and live with over time. Moving away from home for college or work brought its own microbial adventures. New water sources, different cuisines, unfamiliar environments, and the stress of major life changes all left their marks on your invisible organ. That semester abroad in Thailand, the vegetarian phase you went through in your 20s, the period of high stress at work when you lived on coffee and takeout, all of these experiences are written in the shifting populations of your gut bacteria. Pregnancy, if you've experienced it, brought perhaps the most dramatic changes to your microbiome since infancy. During pregnancy, the gut bacterial community shifts significantly, becoming less diverse and more dominated by certain species that help support the developing baby. It's as if your body recognizes that it's no longer just caring for one human, but preparing to seed the microbiome of the next generation. As you age, your gut microbiome ages with you, though not always gracefully. The bacterial diversity that characterizes a healthy adult gut tends to decline with advanced age, potentially contributing to some of the health challenges that become more common in later life. But this isn't inevitable. Studies of healthy centenarians often reveal remarkably diverse and resilient gut communities, suggesting that nurturing your invisible organ throughout life may be one key to healthy aging. The medications you've taken have also shaped your microbial story in profound ways. Antibiotics are the most obvious culprits. These life-saving drugs work by killing bacteria, but they can't distinguish between harmful pathogens and beneficial gut residents. A single course of broad-spectrum antibiotics can reduce gut bacterial diversity by 25 to 50%, and some species may never return to their original levels. But antibiotics aren't the only medications that influence your microbiome. Proton pump inhibitors, commonly used to treat acid reflux, reduce stomach acid production and can allow bacteria to thrive in places they normally couldn't survive. Non-steroidal anti-inflammatory drugs like ibuprofen can alter the gut lining and shift bacterial populations. Even birth control pills have been shown to influence the composition of gut bacteria, though the long-term implications of these changes are still being studied. Your invisible organ has also been shaped by the places you've lived and the lifestyle choices you've made. Growing up with pets exposed you to different bacterial strains. Dog and cat owners tend to have more diverse gut microbiomes, possibly because their furry companions serve as microbial ambassadors from the outside world. Children who grow up on farms, surrounded by animals and dirt and the messy realities of agricultural life, often develop more robust and diverse microbial communities than their urban counterparts. The hygiene hypothesis suggests that our modern obsession with cleanliness, while beneficial in many ways, may have inadvertently impoverished our gut microbiomes. Antibacterial soaps, hand sanitizers, chlorinated water, and sterile environments may protect us from harmful pathogens, but they also reduce our exposure to the beneficial microbes that our ancestors encountered daily. Your stress levels have also left their mark on your microbial companions. Chronic stress triggers the release of hormones like cortisol that can dramatically alter gut bacterial populations, often reducing beneficial species and allowing potentially harmful ones to proliferate. The gut-brain axis works both ways. Stress affects your microbiome, and an imbalanced microbiome can contribute to feelings of anxiety and depression. Sleep patterns, too, influence your invisible organ. Your gut bacteria have their own circadian rhythms, with different species becoming more or less active at different times of day. Shift work, jet lag, and irregular sleep schedules can disrupt these microbial rhythms, potentially contributing to metabolic dysfunction and other health problems. Even your exercise habits have microbial consequences. Regular physical activity tends to promote bacterial diversity and support the growth of beneficial species that produce short-chain fatty acids, important compounds that nourish the cells lining your gut and have anti-inflammatory effects throughout your body. Athletes often have distinctly different gut microbiomes compared to sedentary individuals, with higher levels of bacteria that may contribute to improved endurance and recovery. The foods you've chosen to eat over the years have perhaps had the most profound influence on your gut community. Your microbes are, quite literally, what you eat, or more precisely, what you feed them. A diet rich in diverse plant foods provides the fiber and complex carbohydrates that beneficial bacteria need to thrive. Processed foods, high in simple sugars and low in fiber, tend to favor different bacterial populations, often ones associated with inflammation and metabolic dysfunction. Fermented foods have played special roles in shaping gut communities throughout human history. The yogurt you ate as a child, the sauerkraut your grandmother made, the kombucha you discovered in college, all of these foods delivered live bacterial cultures directly to your digestive system. While most of these transient bacteria don't permanently colonize your gut, they can influence the existing community and provide temporary benefits. Your relationship with alcohol has also influenced your microbial tenets. Moderate alcohol consumption may actually support certain beneficial bacteria, but excessive drinking can damage the gut lining and shift bacterial populations in harmful ways, potentially contributing to liver disease and other health problems. The story of your gut microbiome is, in many ways, the story of your life told through a microscopic lens. Every major life event, every significant choice, every challenge and triumph has left its mark on this invisible organ. And unlike a traditional autobiography, this story is still being written every day, with every meal, every breath, every moment of stress or joy, adding new chapters to your microbial narrative. But perhaps the most remarkable aspect of this ongoing story is that you're not just a passive protagonist. You have the power to influence the direction of your microbial tale, to nurture and support the communities that have been with you since birth, and to create conditions that allow your invisible organ to thrive. Understanding this hidden ecosystem isn't just about appreciating the wonder of biology, it's about recognizing your role as the steward of an extraordinary community that has devoted its existence to keeping you healthy and whole. As we continue our gentle exploration tonight, we'll delve deeper into the specific ways your gut microbiome influences your daily life. From the foods you crave, to the emotions you feel, from your immune system's responses to your body's ability to maintain a healthy weight. We'll meet some of the key bacterial players in this microscopic drama and learn how their different personalities and preferences contribute to the grand symphony of your internal ecosystem. So, as you settle deeper into comfort, perhaps feeling your eyelids growing heavier, take a moment to appreciate the extraordinary journey that brought your gut microbiome to this very moment. Trillions of microscopic companions have traveled with you through every phase of your life, adapting and evolving alongside you, learning your preferences and quirks, becoming uniquely yours in a way that's more intimate than any human relationship. Your invisible organ carries within it the memory of every meal, every adventure, every stress, and every joy. It's a living record of who you are and where you've been, written not in words but in the ever-changing populations of bacteria, viruses, and fungi that call your digestive system home. And what a remarkable community it is. Right now, as you listen to these words, your gut bacteria are engaged in activities that would put the busiest city to shame. Some are busy dismantling the remnants of your last meal, breaking down complex fibers that your own digestive enzymes simply cannot handle. Others are manufacturing essential vitamins, particularly B vitamins and vitamin K, that your body needs but cannot produce on its own. Still, others are standing guard at the intestinal walls, forming protective barriers against harmful pathogens that might try to establish themselves in your system. Think of your large intestine as a vast fermentation facility where bacteria work around the clock like microscopic chemists in the world's most sophisticated laboratory. They take the indigestible portions of your food, those tough plant fibers, resistant starches, and complex sugars, and transform them into compounds that nourish not just themselves, but you as well. The process is called fermentation, and it produces short-chain fatty acids with names like butyrate, propionate, and acetate. These molecules serve as fuel for the cells that line your intestinal walls, help regulate your immune system, and may even influence your brain function and mood. It's a beautiful example of biological recycling. What your body considers waste becomes treasure for your bacterial partners, and their waste products become essential nutrients for you. This ancient partnership is so fundamental that some scientists argue we shouldn't think of ourselves as individual organisms at all, but rather as walking ecosystems, complex communities where human and microbial cells work together for mutual benefit. But not all bacteria in your gut are equal partners in this enterprise. Like any community, your microbiome has its heroes and villains, its helpful citizens, and occasional troublemakers. Let's meet some of the key players in this microscopic drama, starting with the beneficial bacteria that scientists call probiotics, literally meaning for life. Among the most important residents are members of the Bifidobacterium family. These bacteria are particularly abundant in healthy infants and play crucial roles throughout life. They're excellent at breaking down complex carbohydrates and producing vitamins, and they seem to have a special talent for communicating with your immune system, helping it distinguish between friend and foe. When Bifidobacterium populations are thriving, they create an environment that's hostile to harmful bacteria, effectively serving as microscopic peacekeepers in your gut community. Then there are the Lactobacillus species, perhaps the most famous of the beneficial bacteria thanks to their starring roles in yogurt and other fermented foods. These bacteria are masters of fermentation, converting sugars into lactic acid and creating the acidic environment that gives fermented foods their characteristic tangy flavor. In your gut, they help maintain the proper pH balance and produce compounds that support the health of your intestinal lining. The Akkermansia bacteria deserve special mention for their unique lifestyle. These remarkable microbes have evolved to feed on the mucus layer that coats your intestinal walls. This might sound alarming at first, but it's actually beneficial. By carefully managing this mucus layer, Akkermansia helps maintain the integrity of your gut barrier and may play important roles in metabolic health. People with higher levels of Akkermansia often have better glucose metabolism and lower rates of obesity. On the other end of the spectrum, we find bacteria that can cause problems when they grow too numerous or find themselves in the wrong places. Clostridium difficile, for example, is usually kept in check by the other members of your gut community. But when antibiotic treatment devastates the beneficial bacteria, diff can multiply rapidly and cause severe intestinal inflammation. It's a perfect example of how the balance of your microbial community matters more than the presence or absence of any single species. Some bacteria exist in a grey area between helpful and harmful, depending on the circumstances. Escherichia coli, or E. coli, as it's more commonly known, has gotten a bad reputation thanks to food poisoning outbreaks. But most strains of E. coli are actually beneficial residents of your gut. They help with digestion, produce vitamin K, and compete with truly harmful bacteria for resources and territory. It's only when certain pathogenic strains take hold, or when E. coli finds its way to parts of your body where it doesn't belong, that problems arise. The diversity of your gut microbiome matters tremendously. Scientists have discovered that people with more diverse bacterial communities tend to be healthier and more resilient to disease. It's similar to the way diverse ecosystems in nature are more stable and better able to recover from disturbances. A gut community dominated by just a few bacterial species is like a monoculture farm, efficient in some ways, but vulnerable to collapse if conditions change. This diversity isn't just about having lots of different species, though that's important. It's also about having bacteria that perform different functions, like a well-balanced team where everyone has their own specialty. Some bacteria excel at breaking down proteins, others prefer complex carbohydrates, and still others specialize in metabolizing fats. Some are particularly good at producing specific vitamins, while others focus on maintaining the gut barrier or communicating with immune cells. The communication networks within your gut microbiome are extraordinarily sophisticated. Bacteria don't just exist as isolated individuals, they talk to each other constantly through chemical signals, coordinating their activities and responding to changes in their environment. This process, called quorum sensing, allows bacterial communities to make collective decisions about when to grow, when to produce certain compounds, and when to defend against threats. But perhaps most remarkably, your gut bacteria are also in constant communication with you. The gut-brain axis, that two-way highway of information between your digestive system and your central nervous system, is largely mediated by microbial signals. Your bacteria produce neurotransmitters like serotonin, dopamine, and GABA, the same chemicals your brain uses to regulate mood, sleep, and anxiety. In fact, about 95% of your body's serotonin is produced not in your brain, but in your gut, largely under the influence of your microbiome. This means your gut bacteria have a direct line to your emotional state. When certain beneficial bacteria are thriving, they may contribute to feelings of well-being and emotional stability. When the community is out of balance, it may contribute to anxiety, depression, or mood swings. This isn't to say that your gut bacteria control your emotions. The relationship is far more complex and bidirectional, but they are definitely influential participants in your mental health. The immune system connection is equally fascinating. About 70% of your immune system is located in and around your gut, forming what scientists call gut-associated lymphoid tissue. This makes perfect sense when you consider that your digestive system is essentially a long tube that's technically outside your body, constantly exposed to the outside world through the food and drink you consume. Your gut bacteria serve as the first line of defense, training your immune system to recognize threats and mounting responses to harmful invaders. But they also do something equally important. They teach your immune system restraint. Beneficial bacteria help calibrate your immune responses, preventing overreactions that could lead to autoimmune diseases or allergies. Children who grow up with diverse gut microbiomes tend to have lower rates of asthma, allergies, and autoimmune conditions, possibly because their immune systems received better microbial education during those crucial early years. The metabolic influence of your gut microbiome extends far beyond simple digestion. These bacteria help regulate your blood sugar levels, influence how efficiently you extract calories from food, and even affect how your body stores fat. Some bacterial species are associated with lean body types, while others are more common in people who struggle with weight management. This doesn't mean your gut bacteria determine your weight. Lifestyle factors like diet and exercise remain crucial, but they are definitely part of the equation. Certain bacteria produce compounds that can influence your appetite and food cravings. Some species thrive on dietary fiber and may send signals that make you crave vegetables and whole grains. Others prefer simple sugars and may contribute to sweet tooth cravings. It's a remarkable example of how your microscopic partners have evolved ways to influence your behavior in directions that benefit them, and often you as well. The relationship between your gut microbiome and sleep is another area of active research. Your bacteria have their own circadian rhythms, with different species becoming more or less active at different times of day. Disruptions to these microbial rhythms through shift work, jet lag, or irregular eating patterns may contribute to sleep disorders and metabolic dysfunction. Some bacteria produce compounds that promote relaxation and sleepiness, while others may have more stimulating effects. Even your skin health is influenced by your gut microbiome through what scientists call the gut-skin axis. Imbalances in gut bacteria can contribute to inflammatory skin conditions like eczema, acne, and psoriasis. The connection makes sense when you consider that both your gut and your skin serve as barriers between your internal body and the external environment, and both are heavily populated with microbial communities. As we age, our gut microbiomes tend to become less diverse and more fragile. This age-related decline in microbial diversity may contribute to some of the health challenges that become more common in later life, including increased susceptibility to infections, chronic inflammation, and digestive problems. But this decline isn't inevitable. Studies of healthy elderly people often reveal gut communities that rival those of much younger individuals in their diversity and resilience. The story of your gut microbiome is still being written, and you have more influence over the plot than you might realize. Every meal is an opportunity to feed beneficial bacteria or starve harmful ones. Every night of good sleep helps maintain healthy microbial rhythms. Every walk in nature exposes you to diverse environmental microbes that may enrich your internal community. Understanding your invisible organ isn't just about satisfying scientific curiosity, it's about recognizing that you are never truly alone. You are part of an ancient partnership that began millions of years before you were born and will continue long after you're gone. The bacteria in your gut have been with humanity since our earliest ancestors, evolving alongside us, adapting to our changing environments and diets, becoming an integral part of what makes us human. This partnership is so fundamental that some scientists argue we can't fully understand human health without considering the microbiome. We're not just studying human biology anymore, we're studying human microbial ecology, the complex interactions between our cells and theirs, our genes and theirs, our health and theirs. As you continue to settle into comfort tonight, perhaps feeling that familiar pull towards sleep, take a moment to appreciate the extraordinary community that continues its work even as your conscious mind begins to rest. Your gut bacteria are processing the day's nutrition, manufacturing tomorrow's vitamins, standing guard against potential threats, and sending gentle signals to your brain that all is well in their microscopic world. In the morning, when you wake refreshed and ready for a new day, you'll have your invisible organ to thank for much of that well-being. And with each choice you make, what to eat, how to move, how to manage stress, you'll be continuing the ancient conversation between you and your microbial partners, shaping the community that shapes you in return. Tonight, we turn our attention to one of the most revolutionary discoveries about your invisible organ, the profound ways it communicates not just within its own microscopic borders, but with every system in your body. This isn't just casual conversation, mind you. These are sophisticated chemical dialogues that influence everything from the clarity of your thoughts to the steadiness of your heartbeat, from the brightness of your mood to the resilience of your bones. Let's begin with perhaps the most remarkable of these conversations, the gut-brain axis. Picture, if you will, a bustling telegraph network from the Victorian era, with messages flying back and forth between distant cities. Your gut and brain maintain a similar constant communication, but instead of telegraph wires, they use the vagus nerve, the longest cranial nerve in your body, wandering like a meandering river from your brainstem down through your neck, chest, and into your abdomen. This nerve carries messages in both directions. Your brain can send signals down to your gut, which is why you might feel nauseous when you're nervous, or why your stomach might churn during times of stress. But perhaps more remarkably, your gut sends far more messages up to your brain than your brain sends down. Your invisible organ is quite the chatterbox, constantly updating your central command center about the state of affairs in the microbial neighborhoods below. These messages aren't just about digestion, though that's certainly part of the conversation. Your gut bacteria are master chemists, producing an astonishing array of compounds that can cross the blood-brain barrier and directly influence your neural function. They manufacture neurotransmitters, the same chemical messengers your brain cells use to talk to each other. Serotonin, often called the happiness neurotransmitter, is produced in much higher quantities in your gut than in your brain. About 95% of your body's serotonin is manufactured in your intestines, largely under the direction of your microbial tenants. But serotonin is just one player in this neurochemical orchestra. Your gut bacteria also produce dopamine, which influences motivation and reward, GABA, which promotes calm and reduces anxiety, and acetylcholine, which affects memory and learning. They even manufacture compounds that mimic the effects of antidepressants and anti-anxiety medications, though in much smaller more gentle doses. This biochemical conversation helps explain why your digestive system is sometimes called the second brain. The enteric nervous system, the network of neurons that controls your gut, contains more nerve cells than your spinal cord. It can operate independently of your central nervous system, making decisions about digestion, absorption, and immune responses without any input from the brain in your head. Yet it maintains this constant dialogue with your cranial brain, sharing information and coordinating responses. The implications of this gut-brain connection extend far beyond what scientists initially imagined. Researchers have discovered that people with certain psychiatric conditions often have distinctly different gut microbiomes compared to healthy individuals. Those suffering from depression frequently have reduced bacterial diversity and altered levels of specific microbial species. Anxiety disorders, too, show characteristic microbial signatures, with imbalances that may contribute to the persistent worry and fear that define these conditions. Even more intriguingly, studies have shown that transferring gut bacteria from depressed individuals to healthy mice can induce depression-like behaviors in the animals. Conversely, transplanting bacteria from resilient, optimistic humans can improve mood and reduce anxiety in laboratory animals. While we're still far from prescribing specific bacteria as antidepressants, these findings suggest that your invisible organ plays a much more active role in mental health than anyone previously suspected. The communication networks extend beyond the nervous system to encompass your entire endocrine system, the collection of hormone-producing glands that regulate everything from growth and reproduction to metabolism and stress responses. Your gut bacteria influence the production and metabolism of numerous hormones, including insulin, which regulates blood sugar, cortisol, which manages stress responses, and even sex hormones like estrogen and testosterone. This hormonal conversation is particularly evident in the relationship between your microbiome and your circadian rhythms. Your gut bacteria have their own internal clocks, becoming more or less active at different times of day. They help regulate the production of melatonin, the hormone that makes you sleepy, and they influence cortisol patterns, which naturally rise in the morning to help you wake up and fall in the evening to prepare you for rest. When this microbial timing gets disrupted through shift work, jet lag, or irregular eating patterns, it can throw your entire hormonal system out of balance. This is one reason why people who work night shifts or frequently travel across time zones often struggle with sleep disorders, digestive problems, and mood disturbances. Their invisible organs are trying to maintain normal rhythms in abnormal circumstances. The immune system represents another major communication highway between your microbiome and the rest of your body. Your gut bacteria are in constant dialogue with immune cells, training them to recognize threats and calibrating their responses. This education begins in infancy and continues throughout life, with your microbial teachers constantly updating your immune system's understanding of what's dangerous and what's benign. Some bacteria excel at producing compounds that directly support immune function. They manufacture short-chain fatty acids that nourish immune cells, produce antimicrobial peptides that fight off harmful pathogens, and synthesize vitamins that are essential for immune system operation. When these beneficial bacteria are thriving, they create an environment where your immune system can function at its best, alert to real threats, but not overreacting to harmless substances. The conversation between your microbiome and immune system also extends to inflammation, one of your body's most fundamental responses to injury and infection. Beneficial bacteria produce anti-inflammatory compounds that help keep systemic inflammation in check, while imbalanced microbial communities can trigger chronic low-grade inflammation that contributes to a wide range of health problems. This inflammatory connection helps explain why gut microbiome imbalances have been linked to conditions as diverse as arthritis, cardiovascular disease, and even neurodegenerative disorders like Alzheimer's disease. Your invisible organ serves as a kind of inflammatory thermostat, helping to maintain the delicate balance between necessary immune responses and harmful overactivation. Perhaps most remarkably, your gut bacteria communicate with organs and systems throughout your body through the bloodstream itself. Many of the compounds they produce enter your circulation and travel to distant tissues, carrying microbial messages to your liver, heart, lungs, kidneys, and even your bones. This systemic communication network means that the health of your invisible organ has implications for virtually every aspect of your physical well-being. Your liver, for instance, receives a constant stream of microbial metabolites through the portal circulation blood that flows directly from your intestines to your liver before entering the general circulation. Some of these compounds support liver function and help with detoxification, while others can be harmful if they're produced in excessive quantities or if the liver's processing capacity is overwhelmed. The heart, too, listens to messages from your gut bacteria. Certain microbial metabolites can influence blood pressure, heart rhythm, and the health of blood vessels. Some bacteria produce compounds that help maintain healthy cholesterol levels, while others may contribute to arterial inflammation and cardiovascular disease risk. Even your bones participate in this body-wide conversation with your microbiome. Gut bacteria influence the absorption of calcium and other minerals essential for bone health, and they produce compounds that affect bone formation and breakdown. This connection may help explain why people with certain digestive disorders often develop osteoporosis, and why some dietary interventions that support gut health also strengthen bones. The kidneys, those tireless filters of your blood, also receive and respond to microbial signals. Your gut bacteria influence the production of compounds that affect kidney function, and kidney disease can alter the gut microbiome in return. This bidirectional relationship highlights how interconnected your body's systems truly are, with your invisible organs serving as a central hub in the network. Your skin, that largest organ of your body, maintains its own dialogue with your gut microbiome through what scientists call the gut-skin axis. Inflammatory compounds produced by imbalanced gut bacteria can travel through your bloodstream and contribute to skin conditions like acne, eczema, and psoriasis. Conversely, interventions that improve gut health often lead to clearer, healthier skin, a connection that ancient traditional medicine systems recognized long before modern science could explain the mechanisms. The muscles and metabolism represent another fascinating area of gut-body communication. Your bacteria influence how efficiently you extract energy from food, how readily you store fat, and how effectively you build and maintain muscle tissue. Some microbial species are particularly good at producing compounds that support muscle protein synthesis, while others specialize in metabolizing dietary fats in ways that promote healthy body composition. This metabolic conversation extends to blood sugar regulation as well. Your gut bacteria produce compounds that can improve insulin sensitivity and glucose tolerance, while imbalanced communities may contribute to insulin resistance and type 2 diabetes. The timing of this communication matters too. Bacteria that are most active during your normal eating hours seem to have different metabolic effects than those that are active when you should be fasting. The reproductive system also participates in these microbial conversations, though this area of research is still in its early stages. There's growing evidence that gut bacteria influence sex hormone levels and may affect fertility, pregnancy outcomes, and even the development of reproductive cancers. The microbiome changes dramatically during pregnancy, and these changes may help support fetal development and prepare the mother's body for breastfeeding. What makes all of these communication networks even more remarkable is their speed and precision. Your gut bacteria can respond to changes in your diet, stress levels, sleep patterns, or emotional state within hours, sometimes minutes. They then broadcast this information throughout your body via multiple channels: neural, hormonal, immune, and circulatory, creating a real-time update system that keeps all your organs informed about the state of your internal ecosystem. This responsiveness is both a blessing and a vulnerability. It means your invisible organ can quickly adapt to support you during times of stress, illness, or dietary change. But it also means that disruptions to your microbiome from antibiotics, poor diet, chronic stress, or lack of sleep can have rapid and far-reaching consequences throughout your body. The elegance of these communication systems becomes even more apparent when you consider their evolutionary history. Humans and our microbial partners have been co-evolving for millions of years, developing increasingly sophisticated ways to coordinate our biological functions. What we're discovering through modern research is that this partnership runs far deeper than anyone imagined. We're not just housing bacteria in our guts, we're engaging in constant biochemical conversations that influence every aspect of our health and well-being. This understanding is revolutionizing medicine and opening up entirely new approaches to treating disease. Instead of viewing the body as a collection of separate systems that occasionally interact, we're beginning to see it as an integrated ecosystem where your invisible organ serves as a central communication hub, constantly monitoring conditions and coordinating responses throughout your entire biological community. As you continue to settle into comfort tonight, perhaps feeling your breathing slow and your muscles relax, take a moment to appreciate the extraordinary symphony of communication happening within your body right now. Your gut bacteria are sending gentle chemical messages to your brain, encouraging the production of neurotransmitters that promote calm and sleepiness. They're coordinating with your immune system to maintain protective vigilance without unnecessary alarm. They're fine-tuning your hormonal rhythms to prepare your body for rest and restoration. This isn't happening through conscious effort on your part, it's the result of millions of years of evolutionary partnership. A biological conversation so sophisticated and seamless that you're barely aware it's taking place. Your invisible organ is working tirelessly to support not just your digestion, but your entire experience of being human. In the quiet darkness of your intestines, trillions of microscopic partners continue their ancient work, sending messages of health and harmony throughout your body, whispering chemical lullabies that help ease you towards sleep. They are the silent conductors of your body's grand orchestra, ensuring that every system plays in harmony, that every function serves the greater symphony of your well-being. And as you drift closer to sleep, carried along by the gentle currents of neurotransmitters and hormones that your gut bacteria help orchestrate, you can rest assured that this remarkable community will continue its vigilant work throughout the night, standing guard, processing nutrients, manufacturing essential compounds, and maintaining the delicate chemical conversations that keep you healthy, balanced, and whole. The invisible organ working so quietly within you isn't content to simply exist in isolation. It has preferences, opinions, and surprisingly strong reactions to the choices you make each day. Your gut microbiome is perhaps the most responsive organ you possess, shifting and adapting to every meal, every stressful moment, every night of poor sleep with remarkable sensitivity. Understanding what nurtures this hidden ecosystem and what disrupts it is like learning the care and feeding of your most intimate companion. Let's begin with the most obvious influence: food, but not in the way you might expect. Your gut bacteria don't particularly care about calories, macronutrients, or the latest dietary trends that capture headlines. Instead, they're interested in something far more fundamental: the raw materials you provide for their microscopic world. Think of every meal as a delivery of supplies to a vast underground city where different neighborhoods have different needs and preferences. The bacteria that call your colon home are particularly fond of dietary fiber, those indigestible plant compounds that your own digestive enzymes simply cannot break down. While your small intestine extracts what it can from your food, the tough, complex carbohydrates found in vegetables, fruits, whole grains, and legumes travel largely intact to your large intestine, where they become a feast for your microbial residents. But not all fiber is created equal, at least not from a bacterial perspective. Your gut microbiome thrives on diversity, and different types of fiber feed different bacterial communities. The pectin in apples supports one group of microbes, while the beta-glucans in oats nourish another. The resistant starch in cooked and cooled potatoes feeds yet another bacterial population, and the inulin in garlic and onions has its own devoted microbial fans. This is why nutritionists increasingly recommend eating a rainbow of plant foods, not just for the vitamins and minerals they provide, but for the diverse array of fibers that support a thriving, varied gut ecosystem. Each different plant food is like opening a new restaurant in your internal city, providing specialized cuisine for different bacterial residents. Fermented foods deserve special mention in this dietary conversation. Throughout human history, fermentation has been one of our most important food preservation techniques, but it turns out we were accidentally nurturing our gut microbiomes long before we understood what bacteria were. Yogurt, kefir, sauerkraut, kimchi, miso, tempeh, and countless other fermented foods deliver live bacterial cultures directly to your digestive system. Now, most of these traveling microbes don't set up permanent residence in your gut. They're more like beneficial tourists, passing through and providing temporary support to your established bacterial communities. But their visit can have lasting effects, introducing new metabolic capabilities, producing helpful compounds during their stay, and sometimes even helping to suppress harmful bacteria that might be trying to gain a foothold. The timing of your meals also matters to your invisible organ. Your gut bacteria have evolved to expect food at regular intervals, and they've developed their own circadian rhythms that align with your eating patterns. When you eat at consistent times, your microbiome can prepare for incoming nutrients, ramping up production of digestive enzymes and positioning themselves for optimal nutrient processing. Irregular eating patterns, skipping meals, late-night snacking, or erratic meal timing can disrupt these microbial rhythms and contribute to digestive dysfunction. Your bacteria are creatures of habit, much like you, and they perform best when they can predict what's coming next. The temperature of your food provides another subtle influence. Hot foods and beverages can temporarily alter the bacterial environment in your upper digestive tract, while very cold foods might slow bacterial activity. Your gut bacteria prefer the warm, stable environment they've evolved to expect, which is one reason why room temperature or slightly warm foods are often easier to digest. Beyond food, your stress levels have profound effects on your microbial community. When you're under acute stress, your body releases hormones like cortisol and adrenaline that were designed to help you deal with immediate physical threats. These stress hormones don't distinguish between a charging lion and a demanding deadline. They trigger the same physiological responses, including changes to your digestive system that can dramatically alter your gut bacterial populations. Chronic stress is particularly harmful to your invisible organ. Extended periods of elevated stress hormones can reduce bacterial diversity, increase intestinal permeability, and promote the growth of potentially harmful species at the expense of beneficial ones. The gut-brain axis we explored earlier works both ways. Stress affects your microbiome, and an imbalanced microbiome can contribute to feelings of anxiety and depression, creating a cycle that can be difficult to break. But stress management techniques that calm your mind also benefit your microbial residents. Deep breathing exercises, meditation, gentle yoga, and other relaxation practices help restore the hormonal balance that allows beneficial bacteria to thrive. Even simple activities like spending time in nature, listening to music, or engaging in creative pursuits can have measurable effects on your gut microbiome composition. Sleep represents another crucial factor in microbial health. Your gut bacteria follow their own circadian rhythms, with different species becoming more or less active at different times of day. This internal bacterial clock helps coordinate digestive processes with your body's natural rhythms, optimizing nutrient absorption and waste elimination. When you consistently get adequate quality sleep, typically 7 to 9 hours for most adults, you support these natural microbial rhythms. But when you skimp on sleep, stay up too late, or experience frequent sleep disruptions, you throw your bacterial communities out of sync. Shift workers and frequent travelers often show reduced gut bacterial diversity and altered microbial compositions that may contribute to digestive problems and metabolic dysfunction. Creating good sleep hygiene benefits both you and your invisible organ. Regular bedtimes, dark sleeping environments, comfortable temperatures, and avoiding screens before bed all support the circadian rhythms that keep your microbial communities healthy and balanced. Physical activity provides another powerful way to nurture your gut microbiome. Regular exercise appears to promote bacterial diversity and support the growth of species that produce beneficial compounds like short-chain fatty acids. The mechanisms aren't entirely clear, but exercise seems to enhance blood flow to the digestive system, reduce inflammation, and create an environment where beneficial bacteria can flourish. You don't need to become a marathon runner to support your invisible organ. Even moderate activities like walking, swimming, or gardening can have positive effects on your gut bacterial composition. The key is consistency rather than intensity. Your microbiome responds well to regular movement, just as it responds well to regular eating patterns. The environment you live in also influences your microbial community. Exposure to diverse environmental microbes through time spent outdoors, contact with animals, or even just opening your windows regularly can help maintain bacterial diversity. The hygiene hypothesis suggests that our modern obsession with cleanliness, while protective against harmful pathogens, may have inadvertently reduced our exposure to beneficial environmental microbes. This doesn't mean you should abandon basic hygiene, but it does suggest that some exposure to dirt, plants, and the microbial world around us may be beneficial for our gut health. Children who grow up on farms or with pets often have more diverse gut microbiomes, possibly because of their greater exposure to environmental bacteria. The medications you take can have dramatic effects on your invisible organ, with antibiotics being the most obvious culprits. While these life-saving drugs are sometimes necessary, they work by killing bacteria, and they can't distinguish between harmful pathogens and beneficial gut residents. A single course of broad-spectrum antibiotics can reduce gut bacterial diversity by 25 to 50%, and some species may never return to their original levels. If you must take antibiotics, there are ways to minimize the damage to your microbiome. Taking probiotics during and after antibiotic treatment may help maintain bacterial diversity, though the evidence for this is still evolving. More importantly, focusing on feeding your remaining bacteria with diverse, fiber-rich foods can help support recovery and recolonization. Other medications can also affect your gut bacteria, often in subtle ways that aren't immediately apparent. Proton pump inhibitors, commonly used for acid reflux, reduce stomach acid production and can allow bacteria to survive in areas where they normally wouldn't. Non-steroidal anti-inflammatory drugs like ibuprofen can alter the gut lining and shift bacterial populations. Even birth control pills have been shown to influence gut bacterial composition. This doesn't mean you should avoid necessary medications, but it does suggest that being mindful of their potential effects on your microbiome can help you make informed decisions and take steps to support your invisible organ during treatment. Hydration plays a surprisingly important role in gut bacterial health. Your intestinal lining is covered with a protective mucus layer, and maintaining adequate hydration helps keep this barrier healthy and functional. Dehydration can thicken this mucus, making it harder for beneficial bacteria to access the nutrients they need and potentially allowing harmful species to gain advantages. The quality of your water matters too. Chlorinated tap water, while safe to drink, can have mild antimicrobial effects that might influence your gut bacteria over time. Some people find that filtered water supports their digestive health, though the research on this is still limited. Alcohol consumption represents another significant influence on your microbial community. While moderate alcohol intake, particularly red wine, which contains beneficial plant compounds, may support certain bacterial species, Excessive drinking can damage the gut lining and shift bacterial populations in harmful ways. Alcohol can increase intestinal permeability, allowing bacterial toxins to enter the bloodstream and potentially contributing to liver disease and systemic inflammation. The social aspects of eating also affect your invisible organ in ways that researchers are just beginning to understand. Meals shared with others, eaten in relaxed environments, and savoured slowly tend to be better digested and may support healthier bacterial populations. The stress of eating on the run, while multitasking, or during conflict, can negatively impact digestion and potentially alter gut bacterial activity. Temperature extremes can also influence your gut microbiome. Both very hot and very cold environments place stress on your body that can affect bacterial populations. This is one reason why dramatic dietary changes, like switching to very hot or very cold foods exclusively, can sometimes cause digestive upset. Your bacteria need time to adapt to new conditions. Age brings its own influences to your invisible organ. As you get older, your gut microbiome naturally tends to become less diverse, potentially contributing to some of the digestive and immune challenges that become more common in later life. However, this decline isn't inevitable. People who maintain healthy lifestyles throughout their lives often have gut bacterial diversity that rivals much younger individuals. Hormonal changes also affect your microbial community. Women often experience shifts in their gut bacteria during menstruation, pregnancy, and menopause, as hormonal fluctuations influence the intestinal environment. These changes are normal and usually temporary, but they highlight how responsive your invisible organ is to the chemical signals flowing through your body. Even your posture and breathing patterns can influence your gut bacteria. Chronic stress often leads to shallow breathing and tense postures that may affect digestion and bacterial activity. Deep, diaphragmatic breathing and good posture support optimal digestive function and create conditions where beneficial bacteria can thrive. The remarkable sensitivity of your gut microbiome to all these influences might seem overwhelming at first, but it's actually empowering. Unlike your genes, which are largely fixed, your invisible organ responds dynamically to the choices you make each day. Every meal is an opportunity to nourish beneficial bacteria. Every moment of stress management supports microbial balance. Every good night's sleep helps maintain bacterial rhythms. This responsiveness means that positive changes to your lifestyle can have relatively rapid effects on your gut bacterial composition. While it may take weeks or months to see dramatic shifts, beneficial changes can begin within days of adopting microbiome-friendly practices. Your invisible organ is remarkably forgiving and resilient, capable of recovering from temporary disruptions and adapting to new, healthier patterns. Understanding what influences your gut microbiome isn't about achieving perfection or following rigid rules. It's about developing an awareness of this hidden ecosystem and making choices that support the microscopic partners who work so tirelessly to support you. Small, consistent changes, adding more variety to your plant foods, managing stress more effectively, prioritizing sleep, staying adequately hydrated, can have profound effects on your invisible organ and, through it, on your overall health and well-being. As you continue to rest tonight, perhaps feeling your body settling deeper into relaxation, take comfort in knowing that every positive choice you make ripples through your entire internal ecosystem. Your gut bacteria are remarkably adaptable partners, ready to respond to your care and attention with improved function, better communication with your body's systems, and enhanced support for your health. The conversation between you and your invisible organ is ongoing, written not in words, but in the language of nutrients and neurotransmitters, fiber and hormones, rest and movement. It's a dialogue that began before your birth and continues with every breath, every meal, every moment of calm or stress. And unlike many conversations in life, this one always ends with your microbial partners working to support your well-being, no matter what challenges the day may have brought. In the gentle darkness of your intestines, trillions of bacteria continue their ancient work, processing the gifts you've given them today, manufacturing the compounds you'll need tomorrow, and maintaining the delicate balance that keeps your body functioning in harmony. They ask for so little, just consistency, variety, and care, and in return, they offer you the foundation for health, resilience, and vitality that extends far beyond the boundaries of your digestive system. Your invisible organ is waiting, responsive and ready for whatever nurturing choices you'll make when morning comes. Until then, it continues its patient work, a microscopic guardian of your well-being, ensuring that even as you sleep, the ancient partnership between human and microbe continues its quiet, essential dance. The story of nurturing your invisible organ becomes even more personal when we consider how dramatically it can change throughout the seasons of your life and how you can actively participate in writing its next chapter. Unlike the organs you can see and touch, your gut microbiome remains remarkably plastic, capable of transformation that would make a butterfly envious. But this change isn't random. It responds to your choices with the loyalty of an old friend and the enthusiasm of a new pupil. Let's drift into the gentle science of microbial renewal, beginning with what happens when you decide to befriend your bacteria more intentionally. When you start incorporating more diverse plant foods into your meals, your gut bacteria don't just passively accept these offerings, they throw microscopic celebrations. Within hours of eating a particularly fiber-rich meal, certain bacterial populations begin to multiply, like tiny party guests invited to a feast they've been craving. But the most remarkable changes unfold over weeks and months. Imagine your gut as a garden that's been somewhat neglected, with a few hardy plants struggling in depleted soil. When you begin feeding this garden properly with the complex carbohydrates and plant compounds your bacteria adore, it's like adding rich compost and abundant water. Dormant seeds that have been waiting patiently in the soil suddenly sprout to life. New species that were barely detectable begin to flourish. The whole ecosystem becomes more vibrant, more resilient, more alive. This microbial renaissance isn't just about numbers, it's about function. As beneficial bacteria multiply and diversify, they begin producing higher levels of those precious short-chain fatty acids we've mentioned. These compounds don't just nourish the cells lining your intestines, they travel throughout your body, reducing inflammation, supporting immune function, and sending positive signals to your brain. You might find your energy levels stabilizing, your mood lifting, your sleep deepening, all because millions of microscopic workers have found renewed purpose in their cellular factories. The transformation can be surprisingly rapid in some ways, remarkably gradual in others. Your gut bacteria can respond to dietary changes within a single day. Studies have shown measurable shifts in bacterial populations within 24 hours of dietary modifications. But the deeper, more structural changes to your microbial community, the kind that create lasting improvements in health and well-being, unfold more slowly, like the changing of seasons. This is why patience becomes such an important virtue when nurturing your invisible organ. In our culture of instant gratification, where we expect immediate results from our efforts, the gut microbiome teaches us the value of consistency over intensity. It's not the dramatic weekend detox that creates lasting change. It's the daily choice to include an extra serving of vegetables, to choose whole grains over refined ones, to swap that afternoon cookie for a handful of nuts and seeds. Your bacteria are remarkably forgiving partners in this journey of transformation. Even if you've spent years feeding them a diet of processed foods and refined sugars, they don't hold grudges. They're ready to respond positively to better choices whenever you're ready to make them. It's never too late to begin nurturing your invisible organ, whether you're 25 or 75. The capacity for positive change remains throughout your lifetime. But what does this nurturing actually look like in practice? It's far simpler and more enjoyable than you might expect. Think of it as becoming a more thoughtful host to your microbial guests. When you're planning meals, you might ask yourself, what can I offer that will delight my bacterial friends? The answer often involves adding more color to your plate, the deep purple of blueberries, the vibrant orange of sweet potatoes, the rich green of leafy vegetables. Each pigment represents different plant compounds that feed different bacterial communities. Fermented foods become special treats in this new relationship. A spoonful of sauerkraut, a glass of kefir, a bowl of miso soup, these aren't just foods. They're microbial ambassadors bringing gifts from their own fermented communities to yours. While these visiting bacteria may not stay permanently, they often leave beneficial changes in their wake, like houseguests who organize your kitchen before they leave. The art of food preparation also takes on new meaning when you consider your invisible organ. Gently cooking vegetables can break down tough cell walls and make their nutrients more accessible to your bacteria. Allowing cooked starches like rice and potatoes to cool creates resistant starch, a particularly beloved bacterial food that forms when starch is retrograde during cooling. Even the simple act of chewing thoroughly becomes an act of kindness toward your microbiome, as it begins the breakdown process that makes nutrients more available to your bacterial partners. Hydration, too, becomes a more mindful practice. Your gut bacteria live in an aqueous environment, and maintaining adequate hydration helps preserve the protective mucus layers they depend on. Room temperature, water, herbal teas, and water-rich foods like cucumbers and melons all contribute to the fluid balance that keeps your microbial ecosystem functioning optimally. The timing of your meals creates its own opportunities for microbial care. Your gut bacteria appreciate routine almost as much as you do. When you eat at regular intervals, you support their natural rhythms and allow them to prepare for incoming nutrients. This doesn't mean you need to eat by the clock, but rather that finding a sustainable pattern that works for your life also works for your invisible organ. Intermittent fasting, when practiced thoughtfully, can actually benefit your gut microbiome by giving it time to focus on maintenance and repair rather than constant digestion. During fasting periods, certain bacterial populations shift their activities from processing nutrients to producing beneficial compounds and strengthening the gut barrier. It's like giving your microbial community time for housekeeping and infrastructure improvements. The practice of mindful eating takes on deeper significance when you consider your bacterial audience. Eating in a relaxed state, free from distractions, allows your digestive system to function optimally and creates conditions where beneficial bacteria can thrive. The stress hormones released when you eat on the run or while anxious can alter gut bacterial activity and reduce the efficiency of nutrient processing. Movement and exercise become acts of microbial kindness as well. Physical activity increases blood flow to your digestive system, supports the health of your intestinal lining, and appears to promote the growth of bacteria that produce beneficial metabolites. You don't need vigorous exercise to support your invisible organ. Gentle walks, stretching, or even deep breathing exercises can enhance digestive function and create favorable conditions for bacterial health. Sleep, that precious time of restoration, becomes even more important when you understand its role in microbial health. Your gut bacteria follow their own sleep-wake cycles, and supporting these rhythms with consistent sleep patterns helps maintain bacterial balance. The deep, restorative sleep that comes from good sleep hygiene benefits not just your brain and muscles, but the trillions of microscopic workers who continue their essential functions throughout the night. Stress management transforms from a luxury into a necessity when you realize how profoundly it affects your invisible organ. The chronic stress that characterizes modern life can be devastating to gut bacterial diversity, promoting the growth of inflammatory species while suppressing beneficial ones. But the converse is also true. Practices that reduce stress and promote relaxation can have rapid, positive effects on your microbial community. This might involve formal stress reduction techniques like meditation or yoga, but it can also include simple pleasures that calm your nervous system. Listening to music you love, spending time in nature, engaging in creative activities, or sharing meals with people who make you laugh. Your gut bacteria don't distinguish between different types of stress relief. They simply respond positively to whatever helps you feel more relaxed and centered. The environment you create in your home can also support your invisible organ. Opening windows to let in fresh air, keeping houseplants that naturally filter the air, and reducing exposure to harsh chemical cleaners all contribute to a more microbiome-friendly environment. Your skin microbiome and your gut microbiome communicate with each other, so creating conditions that support the beneficial bacteria on your skin also indirectly supports those in your intestines. Perhaps most importantly, nurturing your invisible organ involves developing a sense of partnership rather than control. You can't micromanage your gut bacteria any more than you can micromanage a garden, but you can create conditions that allow them to flourish, and you can trust in their remarkable ability to respond positively to your care. This partnership mindset extends to how you handle setbacks and disruptions. If you need to take antibiotics, you can support your microbiome's recovery by focusing extra attention on feeding beneficial bacteria during and after treatment. If stress temporarily disrupts your bacterial balance, you can be patient with yourself and your microbes as they work together to restore equilibrium. If travel or changes in routine throw off your microbial rhythms, you can gently guide them back to balance with consistent nurturing choices. The beauty of this relationship is its reciprocal nature. As you learn to care for your invisible organ, it responds by supporting your health, energy, mood, and resilience in increasingly noticeable ways. You might find that digestive discomfort diminishes, that your energy levels become more stable throughout the day, that your sleep deepens, or that you feel more emotionally balanced. These improvements aren't just pleasant side effects, they're direct communications from your grateful microbial partners. Some people describe developing what they call gut intuition, a growing awareness of how different foods and lifestyle choices affect their internal ecosystem. You might notice that certain foods make you feel energized while others leave you sluggish. You might become more sensitive to the effects of stress on your digestion, or more aware of how sleep quality affects your appetite and food cravings the next day. This developing sensitivity isn't about becoming obsessive or restrictive. It's about tuning into the subtle communications between you and your invisible organ. It's learning to listen to your body's wisdom, which is often the collective wisdom of trillions of bacterial partners who know your internal environment better than any outside expert ever could. The journey of nurturing your gut microbiome is ultimately a journey of self-care that extends far beyond the boundaries of your digestive system. It's a practice of patience, consistency, and gentle attention that ripples out to affect every aspect of your health and well-being. It connects you to the fundamental truth that you are not just an individual organism, but a walking ecosystem, a community of life that thrives on cooperation, communication, and mutual support. As you continue to settle into comfort tonight, perhaps feeling your breathing slow and deepen, take a moment to appreciate the remarkable potential that lies within your invisible organ. Every positive choice you make in the days and weeks to come will be received with gratitude by your microbial partners. They are ready to respond to your care with improved function, enhanced communication, and deeper support for all the activities that make your life rich and meaningful. Your gut microbiome is not just a collection of bacteria, it's a responsive, dynamic community that grows more vibrant and beneficial with every act of kindness you show it. It's an invisible organ with visible effects, a hidden ecosystem with profound influence on your daily experience of being human. And as you drift towards sleep, carried by the gentle neurochemical lullabies that your well-cared-for bacteria help orchestrate, you can rest in the knowledge that this ancient partnership continues to evolve, continues to strengthen, continues to support you in ways both seen and unseen. Your invisible organ is not just surviving with your thoughtful attention, it's thriving, and in its thriving lies the foundation for your own continued health, happiness, and vitality. In the quiet hours when your conscious mind retreats, your invisible organ shifts into a different rhythm, orchestrating what might be the most important work of the entire day. While you dream of familiar faces and impossible landscapes, trillions of bacterial partners engage in their own nocturnal symphony, one that plays out in the darkness of your intestines with the precision of a Swiss timepiece and the complexity of a great cathedral choir. Sleep, it turns out, is not just restorative for your brain and muscles, it's absolutely essential for your gut microbiome. As your body temperature drops and your breathing deepens, your bacterial communities undergo their own transformation, shifting from the busy work of processing nutrients to the deeper tasks of maintenance, repair, and preparation for tomorrow's challenges. This microbial night shift begins as your last meal finishes its journey through your small intestine and arrives in the vast, slow-moving territories of your colon. Here, in the darkness that has never known sunlight, your bacteria begin their most important work. They dismantle the complex fibers and resistant starches that survived your own digestive processes, breaking them down into those precious short-chain fatty acids that will nourish your intestinal cells and send beneficial signals throughout your body. But this isn't just digestion, it's transformation. During these quiet hours, certain bacterial species that remain relatively dormant during the day become remarkably active. They engage in what scientists call cross-feeding, where the waste products of one bacterial community become the essential nutrients for another. It's an elegant metabolic dance, a microscopic economy where nothing is truly wasted and every byproduct serves a purpose. The timing of this nocturnal bacterial activity is exquisitely coordinated with your body's own circadian rhythms. Your gut bacteria don't just randomly decide when to be active, they follow molecular clocks that have evolved to synchronize with your sleep-wake cycle. This coordination ensures that the production of certain bacterial metabolites peaks at times when your body can best utilize them. For instance, the production of butyrate, one of the most beneficial short-chain fatty acids, often increases during the night when your intestinal cells are most receptive to its nourishing effect. This compound doesn't just feed the cells lining your colon, it travels through your bloodstream, reaching your liver, your brain, and other organs with messages of health and balance. Your bacterial communities also use these nighttime hours for what researchers call quorum-sensing sophisticated chemical communications that help them coordinate their activities. In the gentle darkness of your gut, bacteria are constantly sending and receiving molecular signals, sharing information about nutrient availability, potential threats, and optimal metabolic strategies. It's like an underground telegraph network humming with activity while you sleep peacefully above. The relationship between sleep and your gut microbiome runs deeper than just timing, though. The quality of your sleep directly influences the composition and function of your bacterial communities. When you enjoy deep, restorative sleep, your gut bacteria respond with increased diversity and enhanced production of beneficial compounds. But when sleep is fragmented, insufficient, or disrupted, your microbial partners suffer alongside you. Poor sleep triggers the release of stress hormones that can alter the intestinal environment, making it less hospitable for beneficial bacteria and more favorable for potentially problematic species. The inflammation that often accompanies sleep deprivation can disrupt the delicate mucus layers that protect your gut bacteria, forcing them to divert energy from their beneficial activities to basic survival. This creates what scientists call a bidirectional relationship. Your sleep affects your microbiome, and your microbiome affects your sleep. Certain gut bacteria produce compounds that can influence your brain's production of sleep-promoting neurotransmitters. When these bacterial communities are thriving, they may contribute to deeper, more refreshing sleep. When they're struggling, they may contribute to insomnia, restless sleep, or early morning awakening. The implications of this relationship extend far beyond simple sleep quality. During deep sleep stages, your brain engages in what researchers call glymphatic clearance, a process where cerebrospinal fluid flushes metabolic waste products from brain tissues. Some of these waste products are processed by gut bacteria, creating a connection between your nighttime brain maintenance and your microbial partners. Your gut bacteria also play crucial roles in regulating your body's production of melatonin, the hormone that makes you sleepy, while your pineal gland produces some melatonin in response to darkness. Your gut bacteria manufacture significant quantities of this sleep-promoting compound, particularly when they're well fed with the plant compounds they prefer. The temperature regulation that occurs during sleep also affects your gut microbiome. As your core body temperature drops during the night, your bacterial communities adapt their metabolic activities accordingly. Some species become more active in the cooler environment, while others reduce their activity, creating a natural ebb and flow that mirrors your own physiological rhythms. Even your breathing patterns during sleep influence your invisible organ. The deep, rhythmic breathing of healthy sleep enhances the movement of your diaphragm, which gently massages your digestive organs and promotes optimal bacterial function. The relaxed state of your nervous system during sleep also reduces the production of stress hormones that can disrupt gut bacterial balance. Your position during sleep might seem irrelevant to bacteria living deep in your intestines, but it can actually affect how efficiently waste products move through your digestive system. Sleeping on your left side, for instance, may promote better elimination by working with the natural curves of your colon, while sleeping on your stomach might compress digestive organs and potentially affect bacterial activity. The darkness itself plays a role in supporting your gut microbiome. Your bacterial communities have evolved to expect periods of rest and reduced activity, just as you have. Exposure to artificial light during nighttime hours can disrupt both your circadian rhythms and those of your gut bacteria, potentially leading to metabolic dysfunction and reduced microbial diversity. The fasting period that naturally occurs during sleep also benefits your gut microbiome. This overnight fast gives your bacterial communities time to complete their digestive work without constant interruption from new food arriving. It's like giving them uninterrupted time to finish their projects and tidy up their cellular workspaces. Some gut bacteria actually prefer this fasting state and become more active during periods when no new nutrients are arriving. They shift their metabolism to focus on beneficial activities like strengthening the gut barrier, producing antimicrobial compounds that keep harmful bacteria in check, and manufacturing vitamins that your body will need when you wake. The dreams you experience during REM sleep might seem completely unrelated to your gut bacteria, but even this mysterious aspect of sleep may be influenced by your microbial partners. Some of the neurotransmitters that regulate dream activity are produced by gut bacteria, creating yet another connection between your invisible organ and your sleeping brain. Your gut microbiome also helps prepare your body for the transition from sleep to wakefulness. As morning approaches, bacterial activity begins to shift in anticipation of the day ahead. Certain species become more active in preparation for incoming nutrients, while others begin producing compounds that support energy metabolism and alertness. The cortisol awakening response, the natural rise in cortisol that helps you wake up, is partly influenced by signals from your gut bacteria. This morning, hormonal surge isn't just about getting you out of bed, it's about coordinating your entire body's transition from the restorative state of sleep to the active state of wakefulness, and your bacterial partners play important supporting roles in this daily transformation. The quality of your sleep environment affects not just you, but your microbial communities as well. A bedroom that's too warm can disrupt both your sleep and your bacterial rhythms. Air that's too dry might affect the mucus layers in your respiratory and digestive systems. Even the materials in your bedding and sleepwear can influence the skin microbiome, which communicates with your gut microbiome through complex pathways. The electromagnetic fields from electronic devices might also have subtle effects on bacterial activity, though this area of research is still in its early stages. What we do know is that the blue light emitted by screens can disrupt both your circadian rhythms and those of your gut bacteria, suggesting that the common advice to avoid screens before bedtime benefits not just your brain, but your entire internal ecosystem. Your pre-sleep routine becomes even more meaningful when you consider its effects on your invisible organ. The gentle activities that promote good sleep, reading quietly, taking a warm bath, practicing relaxation techniques, also create the calm physiological state that allows your gut bacteria to shift into their beneficial nighttime activities. Conversely, activities that disrupt sleep preparation, intense exercise, heavy meals, caffeine consumption, or stressful screen time can interfere with both your ability to fall asleep and your bacteria's ability to engage in their essential nighttime work. It's as if your entire body microbe ecosystem needs time to wind down together, transitioning from the active state of day to the restorative state of night. The foods you eat in the hours before sleep can have profound effects on both your sleep quality and your bacterial activity. A heavy meal late in the evening forces your digestive system to work when it should be resting, potentially disrupting both your sleep and your bacterial rhythms. But a light snack that includes foods your bacteria enjoy, perhaps a small serving of cherries, which contain natural melatonin, or a handful of nuts that provide beneficial fiber, can actually support both good sleep and healthy bacterial activity. Alcohol, while it might initially make you feel drowsy, can significantly disrupt both your sleep architecture and your gut microbiome. It interferes with the deep sleep stages that are most restorative for both you and your bacterial partners, and it can alter the intestinal environment in ways that favor harmful bacteria over beneficial ones. The seasonal changes that affect your sleep patterns also influence your gut microbiome. Longer winter nights and shorter summer nights create different rhythms for both you and your bacterial communities. Some research suggests that gut bacterial composition naturally varies with the seasons, possibly in response to changes in daylight exposure, food availability, and activity levels. As you age, both your sleep patterns and your gut microbiome undergo changes that may be related to each other. The lighter, more fragmented sleep that often comes with aging occurs alongside reductions in gut bacterial diversity. While some of these changes may be inevitable, maintaining good sleep hygiene throughout life may help preserve both healthy sleep and a healthy gut microbiome. The medications commonly used to treat sleep disorders can also affect your gut bacteria, sometimes in unexpected ways. Sleep aids that alter neurotransmitter activity might indirectly influence the bacterial communities that produce similar compounds. Even natural sleep supplements like melatonin can affect gut bacterial activity, though usually in beneficial ways. Understanding the relationship between sleep and your invisible organ offers new perspectives on both insomnia and digestive problems. Sometimes, addressing gut health can improve sleep quality, and sometimes, focusing on better sleep can resolve digestive issues. The two systems are so intimately connected that healing often requires attention to both. The emerging field of chrononutrition explores how the timing of meals affects both circadian rhythms and gut bacterial activity. Early research suggests that eating in alignment with your natural circadian rhythms, larger meals earlier in the day, lighter meals in the evening may support both better sleep and healthier gut bacterial patterns. Temperature regulation during sleep affects your gut bacteria in subtle but important ways. The slight drop in core body temperature that occurs during healthy sleep may actually optimize the activity of certain beneficial bacterial species that prefer slightly cooler conditions. This is yet another example of how your body's natural rhythms have co-evolved with those of your microbial partners. The position changes you make naturally during sleep, turning from side to back to side throughout the night, may help promote the movement of contents through your digestive system and prevent the stagnation that could favor harmful bacterial overgrowth. Even in sleep, your body's natural movements serve your microbial community. Your breathing during sleep, particularly the deep diaphragmatic breathing that occurs during restful sleep, provides a gentle massage to your digestive organs and may help maintain optimal conditions for bacterial activity. The relaxed state of your autonomic nervous system during healthy sleep reduces the production of stress hormones that can negatively affect gut bacterial balance. The immune activity that occurs during sleep is also influenced by your gut microbiome. Your bacterial partners help train and calibrate your immune system, and this educational process continues during sleep when your immune system is most active in consolidating the day's learning and preparing for tomorrow's challenges. As you settle deeper into the comfortable embrace of approaching sleep, take comfort in knowing that your gut bacteria are preparing for their own important work. Throughout the night, they'll continue their ancient partnership with you, processing nutrients, producing beneficial compounds, maintaining protective barriers, and preparing your body for whatever tomorrow might bring. Your invisible organ doesn't rest when you do. It shifts into a different gear, one focused on restoration, communication, and preparation. In the gentle darkness of your intestines, trillions of microscopic partners are beginning their night shift, standing guard while you dream, working tirelessly to support your health and well-being. This nocturnal bacterial symphony plays on whether you're aware of it or not, a reminder that you are never truly alone, never without support, never beyond the caring attention of the remarkable community that has made its home within you. Your gut microbiome is your constant companion through every night and day, every season of life, every challenge and triumph. And as sleep finally claims you, carrying you off to whatever dreams await, your bacterial partners continue their vigil, their work, their ancient and essential service to the human they call home. In the morning, you'll wake refreshed, not just by your own rest, but by the countless beneficial activities your invisible organ performed while you slept, the microscopic gifts they prepared for you, the quiet maintenance and renewal they carried out in the darkness. Sleep well, knowing that even in rest, you are supported, nurtured, and cared for by the extraordinary community that lives within you, works for you, and has devoted its existence to keeping you healthy and whole. Your invisible organ asks for so little and gives so much, a testament to the remarkable partnerships that make life not just possible but beautiful. The story of your invisible organ extends beyond the boundaries of your own body, reaching into the most intimate connections you share with others. In ways both profound and surprisingly tender, your gut microbiome shapes and is shaped by the people you love, the spaces you inhabit, and the communities you belong to. It's a reminder that even our most personal biology is fundamentally social, woven into the fabric of human connection in ways we're only beginning to understand. Consider for a moment the person who shares your bed, your meals, your daily rhythms. If you live with a romantic partner, you're engaged in a constant microbial exchange that would make even the most dedicated pen pal envious. Through kisses, shared meals, and simple proximity, you gradually develop similar gut bacterial communities. Scientists have discovered that couples who live together for years often have gut microbiomes that are more similar to each other than to their own biological siblings. This microbial convergence isn't just romantic poetry, it's measurable biology. When you share a fork, drink from the same glass, or simply breathe the same air day after day, you're participating in what researchers call horizontal gene transfer on a macro scale. Your bacterial communities are literally sharing resources, trading useful genetic material, and adapting to create a shared internal ecosystem that reflects your shared external environment. The implications extend far beyond the merely fascinating. When one partner develops digestive problems, changes in diet, or takes medications that affect the gut microbiome, the other partner's bacterial community often responds as well. It's as if your invisible organs are in conversation with each other, coordinating their activities across the boundaries of individual bodies. This biological intimacy suggests that caring for your gut health isn't just a personal responsibility, it's an act of love toward the people closest to you. Children add another layer of complexity to these microbial relationships. If you're a parent, your gut microbiome has been influencing your children's bacterial development since before they were born. During pregnancy, dramatic changes occur in the maternal gut microbiome, shifting toward bacterial communities that support both mother and developing baby. These changes aren't random. They appear to be carefully orchestrated to provide optimal conditions for fetal development and to prepare the bacterial legacy that will be passed on to the next generation. The birth process itself represents one of the most important microbial inheritance events in a person's life. Babies born through the birth canal receive their first bacterial dowry from their mother's vaginal and intestinal communities, while those born via cesarean section begin their microbial journey with different founding populations. Neither path is inherently better or worse, but they represent different starting points for the lifelong development of the gut microbiome. Breastfeeding continues this microbial mentorship, with breast milk serving as both food and medicine for the developing infant gut microbiome. The oligosaccharides in breast milk, those complex sugars we mentioned earlier, exist solely to feed beneficial bacteria in the baby's digestive system. It's remarkable to consider that the human body evolved to produce compounds that have no nutritional value for the human infant, but are essential for nurturing the bacterial communities that will protect and support that child throughout life. Even the family pet becomes part of this microbial ecosystem. Dog and cat owners often have more diverse gut microbiomes than people without pets, possibly because their furry companions serve as walking ambassadors for environmental bacteria. Every time your dog tracks mud through the house or your cat decides your keyboard is the perfect napping spot, they're introducing new microbial possibilities into your shared living space. The home itself becomes a kind of microbial terroir, a unique bacterial ecosystem shaped by the people and animals who inhabit it, the foods that are prepared there, the cleaning products that are used, and even the age and construction materials of the building. Families who live together for years develop what researchers call a household microbiome signature, a characteristic pattern of bacteria that can be detected throughout their living space and, to some extent, in their individual gut microbiomes. This household effect explains why moving to a new home often involves a period of adjustment that goes beyond simply getting used to new surroundings. Your gut bacteria are also adapting to a new microbial environment, encountering different bacterial communities in the water, air, and surfaces of your new space. The dust in your new home carries a different microbial signature than the dust in your old one, and it takes time for your bacterial communities to reach equilibrium with these new conditions. Travel represents a temporary but often dramatic disruption to these stable microbial relationships. When you visit new places, you encounter new bacterial communities in the local water, food, and environment. Your gut microbiome often responds to these encounters with enthusiasm, sometimes picking up beneficial bacterial strains that persist long after you return home. Other times, the encounter is less pleasant, resulting in travelers' digestive upset as your bacterial communities struggle to adapt to unfamiliar conditions. But even these temporary disruptions can have lasting benefits. Exposure to diverse microbial environments appears to strengthen and diversify your gut microbiome over time. People who travel frequently, live in multiple countries, or regularly eat foods from different cultures often have more diverse bacterial communities than those who remain in one place with consistent dietary patterns. The workplace represents another microbial ecosystem that influences your invisible organ. Office buildings, hospitals, schools, and factories each have their own characteristic bacterial signatures. Healthcare workers, for instance, often have gut microbiomes that reflect their exposure to the complex microbial environment of medical facilities. Teachers may develop bacterial communities that are influenced by their daily exposure to the diverse microbiomes of their students. Even your commute affects your gut bacteria. People who walk or bike to work are exposed to different environmental bacteria than those who drive or take public transportation. Each mode of transport carries its own microbial signature, contributing in small ways to the ongoing development of your bacterial communities. The foods you eat carry their own microbial stories, connecting you to the soil, climate, and farming practices of distant places. That apple you ate for lunch carries bacteria from the orchard where it grew. The cheese in your sandwich contains microbial communities that reflect the milk, the aging process, and the specific bacteria used in its production. Even processed foods carry bacterial signatures that can influence your gut microbiome, though usually in less beneficial ways than whole, minimally processed foods. Seasonal changes affect not just your own biology, but the bacterial communities in your environment and your food supply. The gut microbiomes of people living in temperate climates often show subtle seasonal variations, possibly reflecting changes in diet, activity levels, and environmental microbial exposure that come with changing weather patterns. Social interactions themselves have microbial dimensions that we're only beginning to appreciate. The handshake you shared with a colleague, the hug you gave a friend, the high five you offered a child, all of these represent opportunities for microbial exchange. While most of these interactions don't directly affect your gut microbiome, they contribute to the overall microbial environment of your skin and respiratory system, which communicate with your gut bacteria through complex pathways. The stress and joy that come from social relationships also have profound effects on your invisible organ. Positive social connections tend to support gut bacterial diversity and promote the growth of beneficial species. Loneliness and social isolation, conversely, can alter gut bacterial composition in ways that may contribute to inflammation and poor health outcomes. Your bacteria, it seems, are social creatures too, thriving in the context of positive human relationships. Cultural practices around food and eating create their own microbial legacies. Families that regularly eat fermented foods often have gut microbiomes that reflect these dietary traditions. The specific bacterial strains found in traditional fermented foods from different cultures can sometimes be detected in the gut microbiomes of people who regularly consume them, creating microbial connections to ancestral foodways that span generations. Religious and cultural fasting practices also leave their marks on gut bacterial communities. The intermittent fasting that occurs during Ramadan, the periodic fasting of certain Christian traditions, or the regular fasting days observed in some cultures, all create rhythmic changes in gut bacterial activity that may have health benefits beyond those of the fasting itself. The water you drink connects you to your local environment in intimate ways. Municipal water systems, well water, and bottled water from different sources all carry different bacterial signatures. Some of these bacteria are beneficial, others are neutral, and water treatment systems work to eliminate those that might be harmful. But the specific mineral content and trace bacterial communities in your water supply become part of your daily microbial intake, subtly influencing your gut ecosystem. Even the air you breathe carries bacterial passengers that can influence your gut microbiome. Rural air contains different bacteria than urban air. Coastal environments have different microbial signatures than mountainous regions. The bacteria you inhale don't all make it to your gut, but some do, and they contribute to the ongoing evolution of your internal ecosystem. Climate change is beginning to affect these environmental microbial communities in ways that may have implications for human gut health. As temperatures rise and precipitation patterns change, the bacterial communities in soil, water, and air are shifting as well. These changes will likely influence the gut microbiomes of future generations in ways we can't yet predict. The built environment also shapes microbial communities in important ways. Green buildings with natural ventilation and materials may support different bacterial communities than conventional buildings with synthetic materials and closed ventilation systems. The plants in your home and office don't just improve air quality, they also contribute to the microbial diversity of your living spaces. Historical events can even leave their marks on gut microbiomes. The overuse of antibiotics in certain populations, exposure to environmental toxins, or dramatic changes in diet that occur during wars, famines, or periods of social upheaval can create microbial signatures that persist for years or even generations. Your gut microbiome carries within it not just your personal history, but echoes of the broader human experience. The emerging field of social microbiology is beginning to explore how bacterial communities spread through human populations, creating networks of microbial exchange that mirror our social networks. People who spend time together regularly, families, close friends, co-workers, often develop similar bacterial communities, creating what researchers call microbial social groups. These social dimensions of the gut microbiome have important implications for public health. If beneficial bacteria spread through social networks, then interventions that improve gut health in some community members may have positive effects that ripple outward to others. Conversely, practices that harm gut bacterial diversity, such as unnecessary antibiotic use or highly processed diets, may have negative effects that extend beyond individual health to community well-being. The recognition that gut health is fundamentally social is beginning to influence medical practice as well. Some healthcare providers now consider the gut microbiomes of family members when treating digestive disorders, recognizing that successful treatment may require addressing the bacterial ecosystem of the entire household rather than just the individual patient. This social perspective on gut health also suggests new approaches to prevention and wellness, creating environments that support beneficial bacteria through urban planning that includes green spaces, building design that promotes microbial diversity, and community programs that support healthy eating becomes a form of public health intervention that benefits everyone. The implications extend to education as well. Teaching children about the importance of gut health isn't just about individual wellness. It's about creating a generation that understands their role as stewards of both their own microbial communities and the broader bacterial ecosystems that support human health. Even the concept of hygiene is being reconsidered in light of what we're learning about beneficial bacteria. The goal isn't to eliminate all bacteria, it's to create conditions that support beneficial bacteria while controlling harmful ones. This more nuanced approach to cleanliness recognizes that some bacterial exposure is not just harmless, but essential for developing and maintaining healthy gut microbiomes. The foods we choose to support through our purchasing decisions also have social implications for gut health. When we buy from local farmers who use practices that support soil bacterial diversity, we're not just getting fresher food, we're supporting agricultural systems that maintain the environmental bacterial communities that ultimately support human gut health. Community gardens represent particularly interesting examples of how social activities can support gut microbial diversity. People who regularly garden with others are exposed to soil bacteria, plant bacteria, and the bacteria carried by their fellow gardeners, creating opportunities for beneficial microbial exchange while building social connections that themselves support gut health. The sharing of meals represents one of the most intimate forms of microbial exchange in human culture. When families eat together, when friends share dishes, when communities gather for festivals centered around food, they're not just sharing nutrition and social connection, they're sharing bacteria. The potluck dinner becomes a microbial potluck as well, with each dish carrying its own bacterial signature and each participant contributing to and receiving from a collective microbial feast. Traditional fermentation practices often had social dimensions that supported community gut health. The sharing of sourdough starters, the community fermentation of vegetables, the collective brewing of traditional beverages, these practices created networks of beneficial bacteria that supported entire communities. Modern life has largely individualized these processes, but there's growing interest in reviving community-based fermentation as both a social activity and a public health intervention. The intergenerational transmission of gut bacteria creates another layer of social connection. Grandparents who spend time with their grandchildren may pass on beneficial bacterial strains that were shaped by different environmental conditions and life experiences. This bacterial inheritance represents a form of biological wisdom passed down through generations, connecting us not just to our immediate family, but to the broader human story. Understanding the social dimensions of gut health also highlights the importance of addressing health inequities. Communities with limited access to diverse healthy foods, exposure to environmental toxins, or inadequate healthcare may develop gut microbiome patterns that perpetuate poor health outcomes. Addressing these disparities requires interventions that consider not just individual behavior, but the social and environmental conditions that shape bacterial communities. The COVID-19 pandemic provided an unexpected natural experiment in how social distancing affects gut microbiomes. Preliminary research suggests that reduced social contact, changes in eating patterns, and increased stress during lockdowns may have altered gut bacterial communities in ways that could have lasting health implications. As we emerge from this period, understanding these changes may help guide interventions to restore optimal gut health. The future of gut microbiome research will likely focus increasingly on these social and environmental dimensions. Rather than viewing the gut microbiome as an individual characteristic, we're beginning to understand it as part of a larger web of relationships that connects us to each other, to our communities, and to the living world around us. This broader perspective on gut health suggests that caring for your invisible organ is ultimately an act of community care. When you choose foods that support beneficial bacteria, when you create environments that promote microbial diversity, when you manage stress and prioritize sleep in ways that support gut health, you're not just improving your own well-being, you're contributing to the health of the microbial communities that connect us all. Your gut microbiome is not an island. It's part of an archipelago of bacterial communities that spans your household, your community, and ultimately the entire planet. The choices you make ripple outward through these networks, influencing not just your own health, but the microbial legacy you leave for future generations. As you continue to rest tonight, perhaps feeling that familiar pull toward deeper sleep, take comfort in knowing that you are part of something much larger than yourself. Your gut bacteria connect you to your family, your friends, your community, and the broader web of life that encompasses all living things. You are never truly alone. You are part of an ancient, ongoing conversation between humans and microbes that began millions of years ago and continues with every breath, every meal, every moment of connection with others. The invisible organ within you is not just your own, it's part of a collective biological wisdom that belongs to all of humanity, a shared heritage of beneficial bacteria that we pass on to each other through love, care, and community. In nurturing your gut microbiome, you're participating in this ancient tradition of biological gift-giving, ensuring that the microscopic partners who have supported our species for millennia continue to thrive and evolve alongside us. And so, as sleep finally claims, you know that your bacterial partners will continue their work not just for you, but as part of the great microbial community that supports all human life. They are the invisible threads that connect us to each other, the microscopic ambassadors of health and harmony that remind us that we are all, quite literally, in this together.